Okay, today we're going to learn about linear equations again. Uh, we've learned the basic before in the previous discussion. Okay, to remind you again that if we want to solve a linear equation, we just if we have brackets like this, we just need to expand it and then just group together the like terms. Yeah, which is the 6y and negative 7y here, so we can then later find the y. Yeah, so we group all the numbers at the other side, just like that. Now what we are going to learn here today is to also solve a linear equation, but this time involving a fractional equations, involving fractions. Now for example, this one, because we want x, we move the negative 8 first to the other side, or using the textbook method, we just add 8 to both sides. So again, it's just the same thing. See here that because let's take a look at this one. The reason we add 8 to both sides is because we don't want this negative 8. We want to get rid of this negative 8. That's why we do the opposite. We plus 8, right? So negative 8 and plus 8 can be eliminated. So we can have only the 1 over 3x here. Now as a result, oh sorry, as the result, the 6 also got added by 8, and then it will become 14. Now notice it is just the same thing as you move negative 8 to the right side, become positive 8. So 6 plus 8, 14, just the same thing. I think this is more like more understandable for beginners, but once you already get the hang of it, you can just move things around instead of do adding and subtraction to both sides. I think it's kind of just a bit slower, but it's okay. So we'll have 1 over 3x equals 14, and then we want to get rid of the 1 over 3, so we do the opposite. We times 3 times 3 times 3. So 3 times over 3 will become 1, which is 1x, which is just x, and 14 times 3, which is 42. The answer is 42. Or maybe you can just move the 1 over 3 to the right side. When you move fraction, it will become the multiplication of that fraction, but you flip it upside down. So it will become 14 times 3 over 1 upside down. The same thing. So 14 times 3 over 1 is also 42. Okay, so we have 5 over 2y plus 3 over 2. Okay, so equals 2 over 3y plus 5 here. So we have like terms here, 5 over 2y and 2 over 3y. So let's group, either you move it here, group them together, or let's do subtract 2 over 3y first. So we are following the textbook step. Minus 2 over 3y, so this one minus, this one will become deleted, will become eliminated. That's the goal here. So we have only 1y here on the left side, at the left side. So 5 over 2 minus 2 over 3, turn them into like fractions, and then so you times 3 to both 5 and 2, you times 2 to both 2 and 3, so they will have the same denominator, which is 6, and then you will have 15 minus 4 here, which is 11. Right. and then plus 3 of 1 over 2 equals 5. So the constant here, we haven't done anything yet to this, so it just remain the same. They remain the same. And then now we're gonna deal with the number, the constant, and this one is the one that we want to get rid of, right? Because we want only y at the left side. So we subtract 3 1 over 2 from both, and then this one will be eliminated. This one will become 5 minus 3 1 over 2. Yeah, so yeah, do solve the 5 minus 3 1 over 2. Do it your own way. You either turn these both into fractions, this one into the improper fraction, minus them, and then turn that back into the mixed fraction. Or maybe for me, I will just have 5 minus 3 first, which is 2, and then minus half, which is 1 and half. That's my fastest way. Okay, and then lastly, because you want only y's, but you have 11 over y here, so I do you times 6 over 11. Divide, yeah, wait, you have 11 over 6. That means you have to divide by 11 over 6, right? Which means later become times 6 over 11. Remember, when you divide something with fraction, you times with that fraction but upside down. Yeah. So the y is 9 over 11. Okay, what do you do if you have something like this? These are also fractions, but this is actually easier than this one, and then this too. For this one, you just have to cross multiplication. So 5 times z over 2, and 3 times 3z plus 2. Cross multiplication, and we'll get this, right? Or the textbook's way is times 15 to both, the same thing. When you cancel out 3 and 15, you cancel, you have 5 here, right? It's the same thing as moving 5 to here. When you cancel this both, it become 3 here. It's just the same thing as you times 3 to here. So just cross multiplication, and you will get this. And you just expand the bracket, and then there you go. You have this, and then you do exactly the same way as what you learned here, right? The work example 1, number C. Yeah. Okay. So now example 3. Let's see how many. Okay. So solve each of the following equation. Now this one involves also fractions, but I think even simpler. So this one just do kind of like cross multiplication. So this one you times here, just that, only that. So become 9 equals 3 times open brackets 2x minus 5 close brackets. This one. Right? Yeah, what they do here, if they multiply both sides by this 2x minus 5, the goal here is to eliminate the 2x minus 5 here on the left side and the bottom. But as a result, the 2x and minus 5 come out here. Yeah, just again the same thing as what I told you to do just now, like cross multiplication. So this one move to here. You will get 9 equals 3 times 2x minus 5. And then distributive law, expand the bracket. There you go. Very easy to solve after that. And for number B, yeah, cross multiplication also, right? cross, same thing. Let's see. Yeah, so 5 multiply with y plus 4, and then 2y minus 3 multiply with 2, this one, right? Same thing. Haha. And then expand the bracket. See, you get this again, and do exactly the same way again as this one, or this one, or the work example number C also, right? Okay, that's it for the linear equations. Yeah. I understand. Bye bye.